What up, guys? Paradox back with more tech support. We're here today just to kind of go over the overview of what's necessary for a 3.8 or 4.2, just the intake swap. So we're talking about the air intake manifold plenum. That is the uppermost part of the engine. That's going to be usually in contact with the hood. The reason why Ford couldn't put, say, this intake manifold off a 1997 F-150 underneath the hood of a Mustang, it's because it's too high. The clearance is just not going to fit, especially after things with the idle air control valve are still there. So we're going to go over this for you guys. When you change from the Mustang intake manifold to, say, a Freestar, Windstar, F-150, whatever you want for intake manifold, the things that are on the Mustang intake manifold, you're going to have to be able to either take off or remove or re-bracket them for a different placement. So the first thing that you're going to see is that my coil pack's on the side. So you're going to be extending the wires that are on the coil pack. All you're doing is taking an individual wire and extending all of your 4 wires from your coil pack over to the passenger side of your vehicle. With this coil pack bracket, so I actually made this one myself, and this is to show you as complicated as it can get. So this is a 99 coil pack on a 2007 Freestar valve cover. So the thing is down here there's 3 different attachments, 1, 2, and 3, that will put a valve cover coil pack to this. So for your 2001 plus, your coil pack actually goes right to this. It's supposed to. But with mine, I just had an extra valve cover laying around, had a little extra time on my hands, made the bracket, so I was able to put the 99 to the 2004 or later Freestar valve cover that has the mounts on them. This is for the minivans that you can actually just mount your coil pack right to your valve cover. So that's the easy one first. Number 2 is going to be your throttle placement. So when you have your throttle, your Mustang's just a little bit different, and it's where the axis of the fly is away from the intake porthole, and how back it's going to be is different than an F-150 or a lot of the other ones. The Windstar does swap over, the Freestar does swap over, but a lot of the F-150s, 4.2s for sure, you're going to have to make your total X and Y placement of where your throttle holds to your intake manifold. So here is a 2002 4.6 75 millimeter throttle. So this is actually the upgrade for a GT throttle. It's so big that you need to port your manifold porthole on a 4.2. But we're going to end up using this because we have to adjust this X and Y axis anyways. So then I'm actually able to use an Explorer throttle on this, because the Explorer throttle wouldn't line up with a 4.6, and they would have to make an adjustable throttle placement at that point anyway. So I'm actually able to use this at this point directly right in the swap. So it's going to work great. With your throttle placement, really it's just consisting of 3 different pieces. This front piece is going to be a actual mount for the throttle and the cruise control cable for the Mustang. The second piece is just an adapter that fits in the center of here and then over to here. You know, it's just something that makes this piece that actually was on the intake manifold for the F-150 throttle be able to attach to another piece of metal. So you're basically using this center plate to adapt an F-150 cutoff throttle jig to the cutoff of your Mustang throttle jig, and they're pretty resilient. You can put a throttle jig in there and you're not going to have any issues at all hitting your throttle. So you're going to see that this one doesn't line up. Now the thing is what's cool about this is that I'm still going to move the axis. Right now it's at 4.2. I'm going to actually make another plate so I can move this whole thing about 1 inch to the left and use the Explorer throttle. But with that, of course, I'm going to have to port out my intake manifold as well to use the OEM TPS Explorer 70 millimeter throttle on your 4.2 build. So that's kind of really going in there, but I keep doing that. So after your throttle jig, you're going to have your idle air control valve. So with idle air control valves, this is the main problem with a lot of Fords, and the reason is leaking, or once they come off, it's a leak issue, but they have a problem even just kind of running constantly on the vehicle and working great, and it's because of how, so it has to bypass the throttle right here. You see there's an area I've actually cut off, where right here there would be the top half of a tunnel hump, kind of like your transmission, that would go to the backside of the throttle for an area to make a canal that bypasses the throttle plate, so your engine can still get air in a censored value while it's with the throttle plate closed. It's going to get enough air or whatever it wants. So what you're seeing is going on here is I've actually removed the idle air control valve, which is down here. And up here we have tapped that hole. So I've actually used what's going to be on the manifold is going to be a 1/2 inch NPT. What's going to be on the actual idle air control valves itself is usually 3/8 NPT. So there's a difference in size. And you're going to need 2 taps, one for this and one for this. And that's if you decided to do this mod. So a lot of people plate this. So right here you have the ability to put on an old gasket and just slap a plate on there. But I don't like that because that creates a lot of vacuum leaks, especially with boost. So when you're actually putting a lot of compressed air into this same volume of situation, this just isn't going to cut it anymore. You know what I mean? The plate that people try to tell you, you just got to buy a plate. You don't. So when you tap this, you use I use Master Mechanic, but this one's going to be a 1/2 inch NPT thread for that guy, and you're going to have, I don't have the fancy case for it. 3/8 for these guys. So when you have these 2 different taps, what you're able to do is put that tap down into the circle hole that's already on the idle air control valve and tap it. So you would actually be placing this tap down directly into what you'd see is that hole there and putting threads into that hole. So with this is a 1/2 inch NPT cap. I was able to thread that hole, cap that hole, and when I did put permanent JB Weld steel reinforced epoxy around it. So this is a completely sealed hole. That will never open again. I will never have a vacuum issue from that, ever. With this, you're going to go to your idle air control valve. So once you've capped that off, and you know, what are you going to do? So this is how my idle air control valve is running in. You may not be able to see it so well, and I wish I could adjust the camera more, but there is a tube going to directly at the split underneath the intake manifold right here from my idle air control valve. What's going on here is that I've built a metal piece, or a piggyback bracket is what I've come to call this, a piggyback bracket off my alternator to mount. All I'm doing is mounting my idle air control valve. So with these, they're the exact same. If you can get a hold of the 1998 F-150 or the Windstar idle air control valves, they look just like this with the 2 holes where they have a directly tappable point, and you can literally use the same. Well, this one's a 1/2 inch NPT, this one's a 3/8 inch NPT on the idle air control valve, and actually tap threads in that idle air control valve. It takes 5 minutes. I have a whole nother video on it. Check it out, you guys. So once you've tapped this and you're able to put in your own threads and your own fittings, I'm able to bypass the throttle plate with my own completely sealed idle air control valve like this, with the thread tape, and using the different sealants to make sure that this is sealed. You will never, ever, ever have a vacuum leak problem. So that's how you do your idle air control valve, both the tapping and the placement with the piggyback bracket. So with your piggyback bracket, it's just really taking a piece of metal and bending it into a position where you can kind of navigate, and it's just going to mount your thing, you mount the idle air control valve, because your fitting is no longer reliant on being suctioned to a plate. That plate really kind of is a low weak point in their design system and flaw, where if, you know, they're telling you to tap an intake manifold that costs over $100, why wouldn't they be telling you to tap a sensor that's $30? You know what I mean? You can literally just tap the sensor, blow it all out, use sensor cleaner and make sure that there's no metal shavings or shrapnel in there, and then run your fittings on your threads, and you got no issues ever again. As soon as you plug that in, all you'd ever have to do is buy another one of these, thread the new holes, put the new sensor in your placement, and that's the only extra step, is having to thread something. But if you're going to make an intake swap on this car, you're going to have to thread some stuff. So there's no way around it, and I would just like more so get one of these and get one of these sensors from the junkyard. You can pocket all of them, and every single 4.6 is going to have a variation of this. A 4.6 has a variation where the backside, or the introduction port to the idle air control valve, comes in the back of the sensor, so you would be able to run from this side, or have your design, however you'd make it, come from the inside, the backside. Where this is from, I believe, the 2001 Windstar, but I'm not sure. I get these things from Thunderbirds, Windstars, any kind of 4.6. Really, when you walk up, you can just kind of eyeball this idle air control sensor at a junkyard really easy. So I'm going to move past the IAC. This is a vacuum manifold. So with your other designs on Windstar, what they're going to be telling you to do is that you're supposed to use a 3/8 NPT tap, and you're supposed to tap a hole, usually somewhere right around here, for your idle air control valve. Is what they teach you to do, or Dave Seifert's original write-up tells you that's how you're supposed to do it. So with that, a lot of people are scared that you're going to have to actually drill the hole with a step bit and actually tap that hole, and you're going to fuck that up. And to be real, this is an over $100 manifold when you buy them from Rock Auto or wherever, cash. And if it's not from a junkyard where you can get it from $25, where I can just throw these away, that's kind of sketchy for somebody new. You know what I mean? Like, let's just tap this. So with these ones, I like them because they are aluminum. But the thing is that I don't want to tap this unless I absolutely have to. And if I wanted to, that would have been a perfect point. But the thing is I don't want that anymore. I'm moving down to what's called vacuum manifolding. So what you see over here is the empty barb fitting to an empty barb fitting on the manifold. And what this is this is in a large volume of space that is at the back side of this runner and this runner. So when you have air introduction at the front of the manifold, that there's not uneven pressures across your manifold. So say there's only just the one vacuum manifold port on this side, but there's 1, 2, 3, 4 on this side. It's obviously going to have, for vacuum function, depending on what it's doing, if it's just a switch or keeping it closed, or if it actually needs the vacuum air to make it different, pulling more vacuum to this side of a manifold. That's only significant when it's become boosted, because naturally aspirated, you really won't tell a difference. Like, just there's not enough vacuum really being pulled or in the circuit to have it brutally affect it. But when it goes to a boosted system, so boosted, or PSI, is the opposite of vacuum. When you hear vacuum, you're going to have negative PSI, so it's either at 0 or lower. When you have boosted, it's going to be at natural, at higher than atmospheric pressure, and you're going to have boost coming in. So when that happens, now all these different sensors are a little different, because not only are they holding their own pressure, but they're holding against boost, and they have to get the same, or ascertain the same sensing, what they're going to do. So the biggest issue that I found is that, like, the intake runners will flow differently. Say once that throttle plate opens and this is under higher vacuum pressure, the air is thinner on this side, so when the boost comes in, it's actually going to pick this side before that side, because there's vacuum on this side and there's not vacuum on that side in a over or under 0 degrees atmospheric pressure situation. So what's going on is I use this barb fitting to connect to this, and this barb fitting back here to connect to my vacuum manifold, and I'm actually able to run all of my vacuum fittings at once from the back sides of my intake runners. So when the throttle plate opens and it comes in, I'm getting a 100% split air. So it's going to come in, split 100% perfectly, go down, and then into my vacuum. So even things like brake booster and stuff will pull from the backs of the manifold from here back. So by this, you're also able to quit from having to drill or tap the hole under here, and it just makes everything so much easier with manifolds. So when I'm in and out of manifolds, I've been through a Freestar, I've been through clamshells, I've been through, the F-150 aluminum here. I got rid of the Mustang. That's the only one I don't fucking know anymore, to be honest, is the original Mustang. I got rid of it so fast it was like surgery, like in and out. So with this, we're able to run everything, all of my vacuum connections to this. So you're going to have your blender and your Evap pressure solenoid, and then the thing that runs to your air conditioner. You're going to have your, fuel pressure. You're going to have your brake booster, anything that you want. So imagine that this still connected to that, and then I have all of my vacuum running to here except for one, and it makes a big difference. What's called Evap, and what Evap is it's actually your gas tank venting. So there's a hose that's about a 3/8 hose, kind of like this size, coming from your passenger side fender well out into your intake or engine bay area. And what's going on is that's actually your venting fumes from your gas tank. It's from your evap system and why your returnless system works, and it's actually very, 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 very influential to your system. And not to fuck that up, so the first thing I do is I replace that motherfucking hose, because it's a disintegrating type, and the gas isn't made for it, so it actually just eats it up, and it sucks. So I'll replace that hose as soon as I find the evap hose coming from right back here in your engine bay, and I will put always to that one right here where it's split at the throttle and it's literally going to go back both ways, because the Evap is actually made to be a gas vapor and help with combustion and help with the actual making an accelerant or for your vehicle. So with the vacuum manifold, it really just takes a lot of the guesswork out, takes a lot of the fucking bullshit work out. And then with that, you're able to easily swap intakes. Like, so once you know the throttle, how to tap, vacuum manifold, piggyback placements, you'll walk right through an intake. Doesn't matter if it's a Freestar, F-150. And to say how well that works, here it is on a Freestar. So exactly what we just looked at. We're going to have throttle jig, throttle. You can run any throttle doing your XY on your throttle jig. And then the vacuum manifold placements, idle air control. And that's everything. That's the same thing on a different intake. Thank you guys. Stay tuned for more tech support.